So let's do another LCT problem. I put this one in mainly to show that there are some problems that are just idiomatic in the sense that you just kind of have to try different things to see what to compare them to. I've done this problem before, so I know that this works with the comparison to 1 over n squared. Of course, if you try different comparisons and the limit isn't coming out to something that you can use, it's always possible just to try something else until it works. So, but I'll show you the one that does work here. So let's let an equal sine 1 over n, so that's the first sequence, and bn is 1 over n squared. So let's see what happens when we apply the LCT to determine whether this series converges or diverges. We evaluate the limit as n approaches infinity of an over bn, which is equals the limit as n approaches infinity of sine 1 over n, that's an, times the reciprocal of bn. So if bn is 1 over n squared, then dividing by bn is like multiplying by n squared over 1. So in other words, this is an, and this is 1 over bn. So this comes out to the limit as n approaches infinity of n squared sine, actually let me just divide through by this. This is going to be this is going to be n squared divided by n is just n, so this is going to be n times the sine of 1 over n. And one thing you may note here is that this is an infinity times 0 type of limit, which should tell you to use L'Hopital's rule. That's infinity because, of course, as n approaches infinity, n is approaching infinity, and 1 over n is approaching 0, and of course we know the sine of 0 is just 0. So what we want to do is convert this to the form limit as n approaches infinity of sine 1 over n over 1 over n. Multiplying by n is like dividing by 1 over n. We now have a 0 over 0 type limit, so by L'Hopital's rule, we can convert this into the limit as n approaches infinity of the derivative of sine of 1 over n is cosine of 1 over n, and then by the chain rule times negative 1 over n squared. And the derivative of 1 over n is also negative 1 over n squared. So those cancel, and that gives us the limit as n approaches infinity of cosine of 1 over n. 1 over infinity is just 0, so that's just going to equal the cosine of 0, which is 1. Well, we can now conclude that since we got a limit of 1, we know that 0 is less than 1 is less than infinity, not less than 8. It is less than 8, but the important point is it's less than infinity. And we can say that the sum of 1 over n squared converges, and we know that getting a limit of 1 means that the two series behave the same, so we can say, therefore, the sum of sine 1 over n also converges. So there's our conclusion, and we finished our proof.